Alright, so what I plan to do in this video right now is show you how to use Minitab Express as well as the TI graphing calculator to do this insurance example that we've been talking about in this section. So here's the example worked out on the template. Remember, this template's available on Blackboard and also on my math lab. So you could download this template, print it out, it's blank, and of course you could fill it in for each of the hypothesis testing questions that you do. Now this template right here is good for both testing means for one sample of data using the normal and the t-distributions. It does both at once, and that's why you see things like over here it says sigma or s. It asks you what's your distribution, normal since sigma is known. In the testing statistic formula, notice right here it says sigma or s. Obviously you're not putting two things in there. You're either putting sigma if it's given to you or s if it's given. This question here on the insurance example was the population standard deviation. So that's sigma, and that's why it says here sigma is used. So it's I bolded it, but I wrote down here distribution. It says normal because sigma is known. All right, so the most important thing to realize about the software is it's not going to do this procedure for you. What the software is going to do, it is going to crunch two pieces of information. One which is somewhat useful, which is this 1.9 right here. That's the testing statistic. It'll give you that answer, that value. It'll also give you the confidence interval. It may not be the confidence interval you're looking for. Depends on if you have one or two tails. But the most important piece of data, which I deleted it, it's usually right in this area right here. It's on the actual template. It's just when I created this question, I didn't want to leave it blank, so that's why I took it out. But right over here, if you look at the original template, it says p-value. Now the p-value, remember, is a probability value. It's the area outside of this testing statistic, and you can perform what's called the p-value methodology for hypothesis testing. And the p-value method is by far the easiest method because all it requires is that you take that p-value, which the technology will give you, and compare it right here to alpha, the level of significance. The p-value methodology states that if your p-value is greater than this alpha level right here, you will fail to reject the null hypothesis. If your p-value is smaller than this alpha right here, then you will reject the null hypothesis. Now we already know this question here, it rejects. We've already done this question. But the p-value I'm going to get, I know for a fact, is going to be smaller than 5% because I already know what's happening here. But let me show you how to use your software to do this. Now we've used the menu already. There's not much to do other than you give the Minitab software the data, all the inputs. You have to tell Minitab what the alpha level is. You have to tell Minitab that it's a greater than symbol for the alternative. You have to give it this data. You have to tell it that it's a z-score. And then it gives you the rest of the output. And then the only thing is, it's not going to tell you to reject or fail to reject. It's not going to actually do this whole procedure for you. What it's going to do is it's going to give you the information so that you can pass the judgment. Remember, the calculator doesn't have the ability to, come up with an inference. So what we do is we select this inference menu. And as you can see, here's the three hypothesis tests, the trivial ones that you probably learned in Stat 1. We're talking about these two right now. In particular, the one we're talking about is right here, one sample Z. So it's how do I know it's a one sample Z? This is one set of data over here. And I know it's the normal distribution, Z-scores, because we're given the population standard deviation. Remember, if you're given a sample standard deviation, then you would be using the t-distribution. All right, so I'm going to choose one sample Z. A menu opens up. Now we've used this menu already. It's the same menu that we use for confidence intervals. So what do we have? Sample data in a column. No, we don't have data. We don't have the raw data. But there's going to come a time where we perform a hypothesis test where they give you the data, and then you let the software crunch all the stats for you. In other words, if you put all the data down here, you tell me then, hey, go to this column C1 and go grab the data and perform the test. Well, we don't have that. Someone already worked all that data out over here, and we have it. So we have what's called the summarized data. So summarized data, you check that, and notice the inputs all change. So your sample size, that's N. 40 pieces of data in this insurance example. The sample mean, right, that's here, 1950. I'm assuming you've read this question already. You know, I talked about this question in a pencast actually earlier. So, you know, if you want to watch that pencast first, it'll probably help you understand this a little bit better if you haven't seen this yet. The known standard deviation, that's the population standard deviation, that is 500. All right, perform hypothesis test. Yes, I'm going to check that. Now, we haven't been checking this. When we were working confidence intervals, we left it unchecked. And then it says, what's the hypothesized mean? Well, the hypothesized mean is that the average equals $1,800. So we're testing against $1,800. Remember, the sample mean is $1,950. All right, so then some options here. You go to the options, and this is where you select the alternative. So right now, the alternative hypothesis, notice it's set to not equals to, which is a two-tailed test. All right, we don't want that. We need it to be a greater than symbol. So we have to have a greater than scenario there. So I'm changing the alternative to match the greater than situation. And then confidence level, all right, we need to know that. Well, they told us over here that our alpha level is 5%. So remember, if you have 5% alpha, that means you are 95% confident. Okay, so I mean, the only thing to do now is say okay and let it do its magic. So it's going to actually do a couple of things. It's going to crunch this 1.9 for us, which we've done already. But it's also, remember, going to give us this thing called the p-value. So let's see what its output looks like. All right, so here we go. 40, 195, the standard error for the mean. All right, that's the same standard error that we calculated for confidence intervals. 95% lower bound for the confidence interval. So this is a one-sided confidence interval. All right, so they restate the null and alternative. By the way, notice that the alternative they use is H subscript 1. We call it H subscript A. Remember, I mentioned that in an earlier video, I believe. Here's the two big pieces of information that we need. This is the big stuff right here. The Z-value. Well, that's your testing statistic. Remember, it's a Z-score. That's 1.9. All right, there it is. Also, look at the p-value, 0.0289. This p-value right here is smaller than the alpha level. And when the p-value is smaller than alpha, that means the testing statistic lands in the critical region, and therefore you reject the null hypothesis. So you can see, to be honest with you, with just this one number, if you know just this one number, you don't need to label up your picture. You don't need any of the calculation of the testing statistic or critical values. You need two pieces of info: the alpha level and the p-value. If the p-value is smaller than alpha, reject the null hypothesis. If the p-value is greater than alpha, then you fail to reject. So you could pass your judgment very easily by just getting this one number, the p-value. Now, the TI graphing calculator will do the same exact procedure. It does the same exact thing, and it does just as good a job. So in the TI calculator, let's see if it's going to work. My calculator looks like it's not even moving right now. Yeah, it looks like it's frozen. Maybe it'll wake up in a second. Let me try opening it up again for you. Yeah, there it goes. When I create a video, this thing runs really slow. So what I'm going to do is you go to the stat menu. We have to go over to the testing menu. So we have to scroll over twice or move backwards once. And it's the very first option. These first 6 choices are all hypothesis tests. You're going to learn every single one of those, believe it or not. So the first one's called the Z test. That's what we're doing right now. It's called the one sample Z. So you choose option 1. Now, by the way, I showed you how to use a Z interval concept as well. So Z test, you choose it. Now, just like Minitab, let me move this to the side. When I went to inference, and I chose one sample Z, and it says sample data in a column or summarized data. These two choices, the calculator does the same thing. It's like, hey, are you giving me data? In which case, what list is it in? Or do you have this summarized statistics? Well, we have the summarized statistics. So you move this over and hit enter. And then notice the inputs change. And it's pretty straightforward. The hypothesized mean, $1,800. That's like asking you, what is H sub 0 in other words? H sub 0, they read it as mu sub 0. Population standard deviation, 500. By the way, which is why we're using the z-scores, because they give us the population standard deviation. The sample mean, x bar, which is 1950. N, the number of data values, 40. Here's where you select the alternative. Greater than. Alright, not much to do. You on top of calculate, hit enter, and it's going to crunch the same output here. Actually, it's not as detailed. It doesn't give you that confidence interval, but notice what it does give you. The z-score, 1.897 blah blah blah, which is that 1.9 number right there. And then of course the p-value, 0.0288, and here you go, 0.0289. As you can see, Minitab is just rounding for us. So regardless, whether you use the TI calculator or Minitab, you get the same output. Most importantly though is that you understand how to interpret this output. The interpretation of the output is by using the p-value. If the p-value is smaller than the alpha level, reject the null hypothesis. If the p-value is greater than the alpha level, fail to reject the null hypothesis. This method over here on the template, that's called the traditional method of hypothesis testing. It's on a template, uses critical values and critical z-scores and testing statistics. This idea with the technology uses the p-value methodology, and it's a much more modern method, obviously, because of the technology.